moving on to pre-calc topics, you guys. So this first chapter is all about functions and different kinds of functions. Um, we are going to start with linear functions, so I think today will seem pretty basic to you, and then we will move on to things, many of which you've already talked about, but we need to kind of look at them in new notation, because that's a lot of what calc is about, is sort of using different notation to describe some different things. So this first lesson is all about lines, something you're very familiar with, and we will kind of move on. Okay? So again, the general topic for this chapter is all about functions. And of course, functions give us a way to describe the real world in terms of mathematical notation. And you'll sort of see that as we move through this chapter. We are going to talk about a whole bunch of different kinds of functions this chapter. First of all, there's the trig functions. You guys already know that and remember that. Trig functions, you know, are repetitive. They are cyclical. They repeat. They have a period to them. We will go back and review those just a little bit, okay? But trig functions is one kind of function we will study this chapter. We will also study exponential functions, and that's when you raise a power or raise a base to a certain power and the variable is in the exponent. Those are exponential functions. They look something like this. Notice I have this f of x here. You're going to see that a lot in calculus. You're going to kind of not have the y equals so much anymore. You're going to have it in terms of f of x, okay? Then there's logarithmic functions, which are inverses of exponential functions, and we will talk more about those when we get to them, but here's an example of a logarithmic function. Okay, and then there's different kind of logistical functions, which we will look at, things that deal with growth and decay and those kinds of things. And I know this is absolutely Greek to you right now, but we will get to them, and we will study those in the days to come. All right, so first of all, we want to talk about how something changes or how something moves. So we know that I've got this thing right here, and it moves. So for instance, if I start it here at 0 and I move it over there to 2, you know that you moved it 2 to the right. Well, you have to have a mathematical way to record that movement and to describe what happened and to be able to write that on paper and show somebody. So that's kind of what this first thing is about. Okay, I know you know how to figure out how much it changes. What you maybe don't know how to do is how to kind of put that in mathematical notation, especially the kind that's used in calculus, okay? So increments are the distance that a particle has moved in the x direction and the y direction. Okay, so like this particle, if I'm just moving this one right here, it moves from here to here, let's say. Okay, if I want to know its x increment, because that's the only way it can move, and this one is the x increment, you know that you can take x2 minus x1, sort of part of finding the slope, okay? This triangle symbol is also called delta, and delta x means the change in x. That's what that means, okay? And the change in x will be positive if it moves to the right and negative if it moves to the left. So on this one, if I take x2 minus x1, I would go y minus negative 1. Obviously plus plus, and I would get a positive 2. Because it's positive, that tells you it moves to the right. You already know this part. What you don't know probably, though, is this notation, this delta x, which means the change in x. Okay? So that's when you have something in one dimension like that. Then when you move to the right part over here, you know you're basically finding slope. That's what you're doing. But if I'm needing to figure out how this particle moved to get here, it can't just move up and down, and it can't just move right and left. It has to move up and down and right and left. So the x increment, which of course is also known as delta x, okay? The x increment, again, is also known as delta x. And the delta x is how much did it move to get from here to here? Well, if it was at negative 2 right here, and it moved to 3 right there, obviously the x increment would be 5. And then the y increment, or the delta y, would be how much it changed vertically. And so vertically would be from here to here, okay? It starts at negative 4 here, and it moves up to 3. So it moved in a positive 7 direction, okay? So if it asks you for delta x, that means it's the change in x. If it asks you for delta y, that means it's the change in y. All right, clearly that translates to slopes. I don't know why these are all like this, but I'm going to just group them and get rid of that. You know that slopes are rise over run. I know that that is not new information to you. Slope can also be rewritten as delta y over delta x, because the y is your up-down value, the x is your right-left value. Okay. First of all, I want to talk about a couple of specific kinds of lines that we are going to have to deal with here. This has the equation x equals 4, and then we will talk about slopes with them. When you do x equals 4, basically what that means is that the x has to be held constant at 4, and the y doesn't matter. Okay, the x has to be held constant at 4, but the y does not matter. So if you kind of think about this, the x has to be held constant at 4. This is the point 4, 0. Okay, my x value is 4. This is the point 4, 3. My x value is 3, my y is 3, or my x value is 4, my y is 3, my y doesn't matter. This is the point 4, 7. Again, my x is 4, my y doesn't matter anyways. This is the point 4, negative 9. My x is 4, my y doesn't matter. So that's what that means. This gives you a vertical kind of a line, and we will talk about slopes with that in a minute here when we get to the slopes part. But there is a vertical line, okay? Notice it has an x equation. It leads you to believe that it should be a horizontal line because x is the horizontal axis, but that's not what that means, okay? Here we have a y is negative 1. Again, this means that the y is held constant at negative 1. So the y can't change. The x doesn't matter. So the x can change because there isn't even an x in this equation. It doesn't matter what the x is. But I'm going to hold the y constant negative 1. So here I have the point x is negative 1, y is negative 1. X is 3, y is negative 1. X is 8, y is negative 1. X is negative 10, y is negative 1. Notice it doesn't matter what my x is, but I have to have my y's at negative 1. Okay? So there you go. That will be a horizontal line. Again, opposite of what you think. I know you know this stuff, but we need to go over it because it is so, so, so important. All right, then of course, we have all the different ways that you've learned to have slope. I know you know that slope is the rise over the run. I know you know the slope formula, which is right here, and it's in your notes, so if you don't remember it, there you go. Change in y over change in x, also known as delta y over delta x. Okay, and again, that delta means change in y, change over x. I know you know it as rise over run. I know you know it as m. Okay, so none of that should be new to you. What I do want to talk about, though, is some different kinds of slope, okay? So ready? Here's my little elementary slope lesson. Okay, here's how we remember it. You know that you read left to right, okay? So if I draw a little guy on a line, and he has to go like this. This is my line, okay? You always put the little guy on the left side of the line. The only way he's going to stay on that line is if, and you're reading left to right, remember, is if he crawls up the line, okay? So positive slopes look like this. This right here has a positive slope, and what you need to know is this. As your x increases, in other words, as you move to the right, you also move up. So as your x increases, your y increases. Okay, that's what you need to know. Then of course there's negative slopes. Okay, and if you put the little guy on the left, and he's got to stay on the line, and again you're reading left to right, the way he's going to stay on that line is to go down. Okay, and what that means is this. As x increases, in other words, as you move to the right, your y decreases. You move down. As you move to the right, your y value goes down. Okay? Then there is slope of 0. Okay? And what that means is a line that looks like this. If you put a little guy on there and you draw a line that looks like this, he's never going to move up and down. He's not going to go up, he's not going to go down, he's going to remain constant at 0. So this line has a slope of 0. Horizontal lines always have a slope of 0. And then, of course, there's undefined slope, which is different than having 0 slope. But undefined slope is like this. If you put the little guy on the line and you go like that, he won't be able to stay on the line. He is going to fall to his death and be undefined. I know that that's totally cheesy, but that is exactly what happens. Okay? So, there you go. All right. In order to find an equation of a line, you need two things. You need a point on the line, and you need to know the slope of the line. And if you have those two things, you can find the equation of a line in several different forms. Okay? First of all, there's point slope form. I know you know this one. It's on your note sheet. Here is the slope. Here is the point that you will plug something into. Your x1, y1 obviously will start as a coordinate, and that's what you will plug things into. Then there's slope-intercept form. This is the most common form there is. It's y equals mx plus b. This is the one that you enter into your calculator, and this is the one I want you to put your answers in unless I or the book or whatever instructs you otherwise. Okay, so leave your answers in slope-intercept form or have your final answer in slope-intercept form unless I tell you otherwise. And then, of course, there's general form. You probably know this also as standard form. But that's the ax plus by equals c. A and b can't both be 0 because if they're both 0, then all you would have is 0 equals c, and that doesn't make a line. In order for it to be in standard form, your a value has to be positive. If it's not, you're going to switch the signs all the way across. And of course, if it's in standard form, you can't leave anything in fractions. So a can't be 2/3 or whatever. That's not going to work for it to be in standard form. Okay? All right, we are going to do an example. We are going to write an equation for the line, knowing that this is my point right here and that this is my slope. Okay, this obviously is your m value. This I'm going to say is x1 and y1. Okay, so here's your x1, here's your y1. And usually the easiest way to start when you're doing a line is to start like this. This is the most common way that we are going to have you do this, okay? You're going to plug in an equation, and I know I'm going to go through this fast because I know this is not new. So y minus your y1 right here is 1 equals m, which is negative 1/2, times x minus your x1, which you know from up above is 3. Okay? Now, you're going to simplify this. I did not tell you what form I wanted your answer in, so unless I specify otherwise, I do want it in y equals mx plus b form. So y minus 1 equals negative 1/2 x plus negative 1/2 times 3 is 3/2. Okay? And then, of course, if I want it in y equals mx plus b form, I'm going to add 1. So I have negative 1/2 x plus, and then 3/2 plus 1. Obviously, you can get this in common denominators, 2/2. So 3/2 plus 2/2 would be 5/2, which of course is 2 1/2. Okay, so it crosses the y-axis at 5/2, has a slope of negative 1/2. That means you're going to go down 1, right 2 from your y-intercept. Okay, we know that parallel lines, so obviously parallel lines look like this. We know a couple things about them. We know they never cross, and we also know that they have the same slope. Okay, now you need to know this. If there's a special case of parallel lines, okay? So if I think about this as my coordinate grid, and let's say I have this line right here, and I have this line right here. Clearly they have the same slope, but they do not have the same y-intercepts. Their y-intercepts are different, okay? So if they have the same slope and this different y-intercepts, they look like that. They're parallel, okay? But if this is my coordinate grid, and I have a line that is like this, obviously that has a positive slope. Here's the y-intercept. And I graph another line that looks like this, and it ends up right on top of each other. Clearly they're the same line. In both of these cases, you will have lines that have the same slope. It's just that this one has different y-intercepts. This one has the same y-intercept. In both cases, they're considered parallel. Okay. Then, of course, there's perpendicular lines. And I'm going to go back up here. Yeah, oh, I already wrote that. Okay, then, of course, there's perpendicular lines. And perpendicular lines look something like this. I have one line that looks something like that. And I have another line that crosses it somewhere. It doesn't have to be right along the axis, but somewhere they cross, and the angle they meet right here is a 90-degree angle. Okay, so perpendicular lines obviously meet at 90 degrees, meet at a 90-degree angle. And of course their slopes are, if you don't remember this, opposite reciprocals of each other. Here's what that means. If one is 3/2, the other one would be the opposite, which is negative, and then the reciprocal, which is 2/3. Okay, just if you don't remember what that means, there you have it. All right, one last example here. I am going to give you a point in this case. So this is like your x1 and your y1. And then I'm going to give you a line. That's what the L stands for. So part of doing this is just getting used to the notation. The line is right there. So it says, write an equation for the line P that is parallel to L and then perpendicular to L. Okay, so first of all, I want to get this into y equals mx plus b form, right here, the line, the L, so that I can find its slope. So if I get this into y equals mx plus b form, it will be y equals negative 2x plus 4. Okay, this right here is the slope of this line. So the slope of this line is negative 2. Okay, the only reason I'm going to use it is to find the slope of the line that is parallel to it. So in part A, the slope of the line that is parallel to it, we know that parallel lines have the same slope. So up here, the slope was negative 2. Down here, the slope will also be negative 2. Okay, so I'm going to use a slope of negative 2, and I'm going to use the point that I gave you up above, which was negative 2, 2. Okay, and then of course I'm going to plug it into y minus y1 equals m times x minus x1. I'm actually not going to go through that one because I think you can handle it. Okay, then to do part B, which is the perpendicular line. Okay, again, I know that the slope of the line I gave you is negative 2. So the slope of the line perpendicular to it will be the opposite, which will be positive, and then the reciprocal of 2 is 1/2. So you're going to use that, and you're going to use the point I gave you again. So you're going to use negative 2, 2, and again, you will plug this in to y minus y1 equals m times x minus x1. Okay, so I will do this one just so that you can see this. So y minus my y1 is 2. Again, my slope is 1/2, and then x minus negative 2, which of course we know comes out to be boom, boom, so x plus 2. Y minus 2 equals 1/2 x, and then 1/2 times 2 is 1. Add the 2, and y equals 1/2 x plus 3. Okay, now this is the form I want it in, unless I tell you otherwise. If I wanted this in standard form, you guys, I'm going to just do this. If I wanted it in standard or general form, you cannot have fractions in there. So I'm just going to work this out down here so that I'm not messing anything up. If I want it in general form, I can't have fractions in here, so I would multiply everything through by 2, and I would get 2y equals 2 times 1/2 obviously is just 1. 3 times 2 is 6. Okay, in general form, you have to move the x to the other side. So I would have this. And then in general or standard form, your x, this number right here, cannot be negative. So I'm going to switch the signs on everything. And then this is what that equation would look like in standard or general form, just so you know. Okay, so that will do it for this lesson, and we will see you next time.